All right, so in my random sample of 10, we had the following amounts for sleep. All right, so here is our sample data. We have 8, 7, 4, 6, 6, 9, 6, 7, 4, and 3. I want you guys to calculate the sample mean and the standard deviation. Find the sample mean and the standard deviation. Yes, you may. All right, who's got a sample mean for me? 6. X bar is 6. And standard deviation. .89. Why don't we go 1.886? Just so we don't have to, since it's that 5, that's just kind of a weird one. All right, so SX 1.886. All right. So I want to know if the data collected from my sample provide convincing evidence that AP Stat students get less than 8 hours of sleep per night at the alpha equals 0.05 level. So I want you guys now to write down appropriate hypotheses for that and define your parameter. Yep. This is basically exactly what we did in Module 9. Or not Module 9, Chapter 9, whatever they call it. Except we're doing it with means instead of proportions now. I don't see it. Nobody handed me one, and I don't see it at your desk. Sorry, dear. What is my parameter, by the way? Yep. Would that be P equals? Mu equals the true mean, or the true average amount of sleep for, and we want to be careful because remember, we're talking about the population here. The true mean amount of sleep for AP Stat students, for all AP Stat students. If you talk about my stat students, then we're only talking about the sample, right? What would the appropriate null hypothesis for that be? Mu equals 8. What about for the alternative hypothesis? Mu is less than 8. Absolutely correct. All right, let me see if I can get this up higher on the screen here. There we go. There we go. What conditions need to be met? Random, independent 10%, normality. I would like you guys to check those conditions. I'll give you about a minute and a half to check conditions. It's a random sample. Somebody really did.
Like, maybe you can like speak up. Give me your speaker. Give me your name card. Like,
I would if I was not absolutely horrible at basketball. So in the interest of the staff beating the students, I decided to do my part by backing out.
Are you going to go watch?
I can't. Only 6 of my 7th period students are going, so I have to stay and supervise all the rest of them.
Wait, it's during school?
Yeah, it's during 7th period.
Today?
Yep.
Yeah.
Oh.
We love this play. Next year.
Do we get random?
Why?
Random sample of 10 students. Oh, I know whose that is.
Oh, it's the phone.
At first I thought it was like an Amber Alert or something.
Vibration.
Virus is
I've never heard of vibration that hard.
All right.
It was so hard.
Yeah, it's on the metal tray. Do we get independence? How do we check for independence here? 10 is less than or equal to 0.10 all AP students? All AP stats students. So the assumption that we're making is that there's at least how many AP Stats students? At least 100.
The panel will enter standby in 50 seconds.
I'll be there in a second. I'll be there in less than 50 seconds. How's that? Do we get normality? Why? Draw a dot plot. We got to make sure there's no outliers or strong skews. So here's my dot plot. It needs to go from what to what? From 3 to 9. 3, 4, 5, 6, 7, 8, 9. So how many dots on each one? 1 on 3, 2 on 4. Okay, 2 on 7, 1 on 8, 1 on 9. So can I leave it like this? Got to label it. What do I need to label about it? Yeah, we say no strong skew or outliers. But then I also have to label what this is a dot plot of. Hours of sleep for hours of sleep for AP stats students. For this one, you could put Ms. Bolt's AP Stat students, but remember, we're supposed to be taking a sample from the whole population, and the whole population here would be all AP Stat students. Yes.
Wait, so if you forget to like put the name, it goes from an E to a P? Like hours of sleep for AP stat students? Like, what
I'm not 100% that would go from an E to a P. I got to double check and look a little bit closer at the scoring guidelines to be able to answer that. I want you guys to look up the formulas for mean and standard deviation of the sampling distribution and then calculate those values. How do we find the mean for the sampling distribution? Yeah, mean of X bar is equal to, it's not X bar here, but it is mu. And what did we assume mu was? 8. So mu X bar is 8. How do we calculate the standard deviation of the sampling distribution? Yes. SE of X bar is equal to SX over the square root of n. What was our SX? 1.886 divided by square root of 10. We looked for it, but it's over there on the tray. It scared everybody. What is our standard deviation? 0.596. Draw a picture. What do they mean by draw a picture? Bell curve. Mine's huge. Sorry about it. Right in the center should go what? 8. And here? Was it 556? Did I write it down? 596. I might have written it down wrong. Is it 556 and I misheard it? 596. Okay. You just said 556. That's why I was asking. I was like, maybe I wrote it down wrong. Okay, 0.596. What else needs to go on my picture? What else should go on the picture? What'd you say? Less than 8. Specifically, what number? 6. So over here, why 6? That's our sample mean, yes. We found it up at the top. There is one more thing that my picture needs.
Your approximately normal label.
My approximately normal label, except we had to estimate for the sample mean, or estimate for the mean of the sampling distribution, right? And we had to estimate for the standard deviation because we don't know the population standard deviation. So are we using an actual normal curve here? No, we are using what kind of distribution? T distribution. So instead of n, I need t. Honestly, I just drew it poorly. Inside the parentheses, we don't have to give two numbers here. We give only one number, just degrees of freedom. How many degrees of freedom do we have? 9. So then there's actually one more thing that I need to do to this. We don't need to put standard deviation on this type of a picture because it's a t distribution, not a z. When we do our normal curves, we put in the standard deviation and we have our mean right here, but because we're using a t curve, we have to fit our data to a t distribution. So instead of 8 right here, we put a mean of 0. And over here, we are going to put our test statistic. So we're not going to put this either. We need to go and find our test statistic. Do you guys remember how to find a standardized test statistic? There we go. Test statistic is statistic. Yes. Minus parameter. Divided by the standard deviation. This time, instead of my test statistic being z equals, this is t equals. What was our statistic? 6 minus the parameter, 8, over the standard deviation, 0.596. The sample standard deviation? Yeah, because that's all we have to work with. That's the only standard deviation that we have, and that's why we have to use a t statistic instead of a z. So I've got -2 over 0.596, which comes out to be what? $3.36? 3.56. Is that what everybody else got? Please double check it for me because I'm not doing it on my calculator. Okay, so here's our test statistic. So t equals -3.56. 3.356? Yeah. Okay, I'm like mishearing things all over the place, guys. -3.356. Speak up. All right. That is what we need to put right here. -3.356. What is that telling us? How many standard deviations we are away from the mean in our t distribution. So we are more than 3 standard deviations away on the left-hand side. All right, let's keep looking. I'll put 5 back up there, don't worry. Since we're working with means, the test statistic is a t-value. So we can either use table B to find our p-value, or we can use our calculator. Do we do normal CDF for this? No, we do which one? T-CDF. You can look this up on table B. We have how many degrees of freedom? 9 degrees of freedom and a t-score of -3.356. If I want to use my calculator, we want less than, right? So I would put like what, -1,000, and then I would put my t-score -3.356. So I've got my lower bound, my upper bound, and then the last thing I need to include here is my degrees of freedom. t-distribution, if you look on your calculator, we want t-CDF, which is option number 6. Same place where we go for normal CDF. T-CDF is in the same spot. And then we put our lower bound in, our upper bound in, and our degrees of freedom. And we get what for our p-value? 0.0042. So what kind of conclusion can we make at the alpha equals 0.05 level? Sample mean, yep.
Of 6 purely by chance,
Mm-hmm.
or 6 purely by chance.
6 or less, purely because remember our null hypothesis was less. So assuming HO is true, mu is equal to 8. There is a 0.0042 probability of getting a sample mean of 6 or less purely by chance. Because 0.0042 is less than or greater than our alpha level. Less than 0.05, which is my alpha. What do we do with that information now?
I mean, we do have.
We do. So we reject HO. We reject the HO. And have convincing evidence of what? There we go. That AP stats students get less than 8 hours of sleep a night. The faster I write, the messier my handwriting is. Sorry, guys. Feel familiar?
Mm-hmm.
We haven't practiced writing our conclusion like that with a p-value in a while. But we've done it one other time in chapter 9. All right, so conditions. Got to meet random, got to meet 10% for independence, got to check for normality. We got 3 ways to check for normality. The fastest, easiest is it says the population is normally distributed. And then all we have to do is reference that and we're done. The other option is central limit theorem, which would mean n is 30 or more. Is exactly 30 okay?
Yep.
Yes, 30 or bigger. If all else fails, then we draw a dot plot. But that is our last resort. After the other 2 are like, nope, can't do that, don't have that. Standardized test statistic, our p-value. T is equal to x bar minus mu divided by Sx over the square root of n. And then to find our p-value, again, you can use table B, or you can use your calculator with t-CDF. When we do our t-curve, which is kind of like a normal curve, has the same basic shape, our bell-shaped curve, it's t with the degrees of freedom, And the mean for this is always 0. You put your test statistic, your t-value, on the picture. Let me actually add that to my picture here. That's where t would go. Or on the other side, depending on how big or small your t-value is. I would like you guys to try state, plan, do, conclude on the check your understanding. Yep. I'm going to give you guys 10 minutes to do this, and then we'll go through it together. If you want to work together, please do so. But you guys have 10 minutes to work. All right, so we will go over the check your understanding on Monday. The test, by the way, over this chapter, the test will be March 6th. That's a Wednesday, not next Wednesday, but the following. So this is another fairly short unit. We will be all the way done with all the notes by Thursday next week. So then we'll have Friday, Monday, Tuesday to review, test on Wednesday. That Thursday, the 7th, only juniors will be at school because that is SAT day. So we will not be covering any material on the 7th. We'll take our test on the 6th, and we will start our very last chapter that Friday, the 8th. Oh, sorry, homework's due Tuesday. Homework is due Tuesday.